Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dani Haikal bin Azlan. So right now, I'm gonna present pre-lab liquid extraction, which is extraction of acetone from water using toluene. First, background theory of the experiment. Liquid extraction, also known as LLE, is an alternative to consider when separation by distillation is ineffective or very difficult. Liquid extraction is a process that separates the components mixture based on their relative solubility in two different immiscible liquids. Unlike distillation, LLE separates components based on chemical differences instead of vapor pressure differences. Binary solution and solvent are fed concurrently into the rotating disk extraction column. Binary solution will fed at the top of the column and flow downwards, while the solvent will fed at the bottom of the column and flow upwards because of the density differences. This countercurrent flow allows contact between those two immiscible liquids. This contact causes the extraction of solute by solvent from the binary solution. Then the solvent-rich phase will emerge at the top of the extraction column, which is extract, and the carrier-rich phase will emerge at the bottom of the column, which is raffinate. The next one is objectives of the experiment. First is to operate a liquid extraction experiment using a rotating disk column. Second, to determine the high equivalent theoretical plates, also known as HETP, for the column. And the last one is to investigate the effect of the solvent to feed flow rate ratios and rotating disk speed on the HETP. Next, this is process flow diagram or PFD of the experiment. So I'm gonna introduce the component of the liquid extraction unit. First, feed vessels B1 and B2. Second, rotating disk column K1. Third, dosing pumps B1 and B2. Fourth, receiving vessels B3 and B4. And fifth, pulsation dampers B5 and B6. Next is general startup procedures. First, prepare mixture of acetone water solution at the desired composition and also pure toluene. Second, ensure that all valves are closed. Third, ensure the feed vessel B1 is filled with pure toluene and feed vessel B2 with acetone water solution. Fourth, turn on the main switch at the control panel. Fifth, open ventilation line valve 18, valve 19, valve 20, valve 21, valve 11, valve 13, and outlet vessel valve 2 and valve 7. 6. Switch on the pump 2. Allow the acetone water solution heavy phase to enter the column and fill to a level of about 100 cm above the solvent inlet. Then stop the pump P2. 7. Switch on the pump P1. As the pure toluene light phase enters the column, carefully watch the interface level which forms between the light and heavy phases. Maintain the interface level at 100 cm above the solvent inlet by adjusting the height of the overflow tube. 8. Once the liquid starts to overflow at the top of the column, stop pump P1. 9. Switch on the stirrer. 10. The unit is now ready for experiment. And the last one is switch on the PC to open Soldas software. The speed of controller are now ready to control using stirrer controller or from Soldas. After perform the general startup procedures, now the experiment procedures. First, start both pumps P1 and P2 and set the desired feed and solvent flow rates by adjusting the pumps frequencies and displacements. Next, Allow the both liquids to flow into the collection vessels B3 raffinate and B4 extract respectively. The bottom product contains the water-rich phase raffinate, while the top product contains the toluene-rich phase extract. Next, monitor the interface level. Maintain it at about 100 cm above the solvent inlet by adjusting the height of the overflow tube. Once done, both collections vessels B3 and B4 are filled with sample product. Start to collect the samples. Open valve 12 to collect the sample of raffinate and open the valve 14 to collect the sample of extract. Start the stopwatch and continue to collect the product samples at every in a 2-minute interval until the refractive index values are constant. Record the refractive index values of both samples until constant and use the calibration curve Appendix D to determine the acetone solute composition in each phase. Record all data in the sample table in Appendix A and stop both pump P1 and P2. Repeat the experiment step 3 to 10 by turning on the rotating stirrer and set the stirrer speed at 250 rpm but fix the same flow rate and feed composition throughout the whole experiment. After finish with the experiment, proceed with general shutdown procedures. First, switch off the pumps P1, P2 and rotating stirrer. Second, open valve 12, 14 and 16 to drain all liquid from the equipment. Third, wash the column until clean by using mixture of acetone water through pump 2. Fourth, close valve 2, valve 7, valve 12, valve 14, valve 16, valve 18, and valve 19. And the last one is shut down the PC and turn off the main switch at control panel. Next, how to collect data or result. First, open valve 12 and valve 15 to collect the sample product of raffinate and extract respectively at every 2 minutes interval until the refractive index values are constant. Second, obtain their refractive index readings using a refractometer. Third, record the refractive index values of both samples until constant and use the calibration curves at Appendix D to determine the acetone which is solute composition in each phase. And the last one, record all data in the sample table in Appendix A. Next is missing data and how to obtain the data. First, missing data is required to theoretical extraction stage, and how to obtain is to refer Appendix B. Second, high equivalent theoretical plates or HETP of the extraction column for different rotating disks, and how to obtain by HETP formula. Third, separation efficiency for different solvent to feed ratios and rotating speed can obtain by efficiency formula. And the last one is composition, also can obtain from composition formula. Okay, so this is a formula that we will use to calculate the data. First is a HETP formula, which is equal to effective column height divided by number of theoretical plates. Second is separation efficiency, which is equal to amount of extracted solute divided by amount of solute in feed, also equal to multiple of extract flow rate and extract composition divided by multiple of feed flow rate and feed composition. And also a composition formula, which is mole fraction XA equal to number of moles A divided by total number of moles. Second, mole ratio XA over P equal to number of moles A over number of moles B. Next is mass fraction XA equal to mass of A over total mass. And the last one is mass fraction XA over B equal to mass of A over mass of B. Okay, so the last one is the expected result. For the experiment, what we expect is knowing the high equivalent theoretical plates HETP for the column, and also can identify the effect of the solvent to feed flow rate ratios and rotating the speed on the HETP. So this is my reference that I have referred while making these slides. So that's all from me. Thank you.